So, you've made a hypothesis and now you're ready for an experiment. Is there anything else you should know? The short answer, yeah. All experiments have what are called variables. A variable is any factor or item, basically any one thing that can exist in your experiment. It could be the amount of something, a unit of measure, results from a quiz, seconds it took to run around the track. Basically, it could be anything. Experiments have two types of variables, an independent variable and a dependent variable. The independent variable is any factor that is manipulated in an experiment. You control it. A good way to remember is that independent variable, I control. I. Independent, I control. Take, for example, one of our hypotheses from earlier. If a person drinks more than 1 cup of coffee, then they will perform better on a reading comprehension quiz. We're testing to see if the amount of coffee a person is given improves their reading comprehension ability. In this experiment, you're changing the amount of coffee. So the amount of coffee is our independent variable. Now, experiments also have dependent variables. A dependent variable is the change that occurs as a result of the independent variable. It's the data that you usually look for and write down. Dependent variable data, dependent data. You get it? In our experiment, we're testing to see if coffee has an effect on reading comprehension. So, our plan is to give volunteers a bunch of quizzes after they drink coffee and see how they do. Those scores would be our data, or dependent variable. Just think about the excitement and awesomeness of grading dozens and dozens of reading quizzes. Or not. So, I have identified my independent variable, the amount of coffee, and dependent variable, the quiz score results. Now, everything else in the experiment must be controlled. Remember, an experiment is under controlled conditions. So if we were to change the amount of coffee in the experiment, everything else must be the same. The same brand of coffee, the same amount of coffee in each cup, the same time of day my volunteers drank their cups of coffee, the time after they drank their coffee to administer the quiz, the kind of reading quiz I plan on giving them, the age group, and so on and so on. Although they want to constantly be in the driver's seat, there are some things that scientists just can't control. These are called nuanced variables. Tiny temperature differences or noise levels within a lab room would be a pretty good example of a nuanced variable. Can you think of any nuanced variables that we could encounter in the coffee experiment? Okay, we have our experiment set up and now all I need are volunteers. The more the better. Having a large sample size or performing many trials in an experiment is good because it makes your data more accurate. You see, in science, sometimes things just don't come out the same way each time you do them. Would you perform exactly the same on a reading quiz each time you took it? Would you expect everyone in your age to jog 1 lap around the track at the same time? Would you expect the daily temperature to be exactly the same day during the season? Large sample sizes accounts for deviations from a central tendency, or in English, the trend you discover in your data will take into consideration the numbers that seem a little bit off. Once I have my volunteers, I would then break them up into 2 groups, the experimental group and the control group. The experimental group is the group that receives the variable I am testing while the control group does not. By comparing the results of the 2 groups in my experiment, it will allow me to see if the amount of caffeine is the sole reason for how well they perform on their quizzes. Okay? Identifying the independent and dependent variables in an investigation is important because it gives you better control over your own experiment. But if you're ever stuck or unsure of what they are, not to worry. Your hypothesis tells you what they are. If a person drinks more than 1 cup of coffee, then they will perform better on a reading comprehension quiz. The independent variable in our experiment is the amount of coffee. It's what I'm changing. The dependent variable is the performance on their reading quizzes, the scores, the data. So if you're ever stuck on making a hypothesis of your own, think about how the independent variable will change and what to look for in your observations. They're ingrained in all hypotheses. This makes what to include in writing a hypothesis, designing the experiment, and how you're going to collect your data much, much easier. And cut.